Hello friends, welcome to my channel. Let's have a look at problem 2256, minimum average difference. In this video, we're going to share solutions based on partial sums. So first, I'll read through the problem statement to digest the problem requirement, and then we analyze the idea and doing the coding. So first, let's look at the problem statement. So we are given a zero-indexed integer array nums of length m. The average difference of the index I is the absolute difference between the average of the first I plus 1 elements of nums and the average of the last n minus I minus 1 elements. Both averages should be rounded down to the nearest integer. So we are required to return the index with the minimum average difference. If there are multiple such indices, return the smallest one. So the notes here are important. First, the absolute difference of two numbers is the absolute value of their difference. The second one is that the average of n elements is the sum of the n elements divided by n. Here, the division is integer division. So this is an important thing for this problem. The third one is that the average of 0 elements is considered to be 0. So with that, I'm done. So let's look at the examples. So for example, in example 1, right, the sum is 0, so the average is 0. So in this problem, in this example, also the output is 0. So in example 1, the output is 3. So you can look at the explanation to digest this output. So before we do the analysis, let's look at the constraints. First, the length of this list is bounded below by 1. In other words, it's not empty, and bounded above by 10 to the power 5. In other words, so this number 10 to the power 5 provides a upper bound for the problem size. So secondly, the elements in the list is non-negative and is bounded above by 10 to the power 5. So with that said, so we are ready to do the analysis and do the coding. So here we are going to use partial sums. So the idea is to compute the prefix and suffix partial sums and then do the averages. So actually for this problem, we could use either prefix sum or suffix sum. So we just need to use one of them. Or if we would like, we can use two, both the prefix and suffix sum. So as such, in this video, we are going to share two formats of solutions. So in the first version, we are going to use both prefix and suffix sums. And in the second version, so we are going to use one of them. So we're going to use just a prefix sum. First, let's look at the solution we want. So here I'm going to use prefix and suffix sum. So this is actually very straightforward. First, I'm going to get the length of this list. So this is the total elements, right? In order to get the minimal average and the corresponding indices, so we're going to introduce two variables. Average difference, this will be a global one, so we are going to set it to be a large one. Let's see, float infinity, right? And also the index is what we want to return, and initially I'm going to set it to be -1. So we want to find the smallest one, right? So with that said, so we are going to find the smallest one, so we can pick a large one. Let's see, n plus 1 at the very beginning. So then, in order to use the prefix sum and the suffix sum, I can actually use an O(n) space. So though we can use O(1) space. Let's first define this. Pre is so I'm going to use a copy function, and the suff nums copy. So I'm going to use the pre and the suffix to store the prefix sum up to an index I, or suffix sum on and after an index I. So for this, I'm going to set up the pre and suffix for this purpose, this is very easy. So for I in range, so 1 to n. So here I'm starting with 1 because the first element will be also the prefix sum of itself. So this is easy to set. So we're going to set prefix I equals prefix sum I minus 1 plus the current number, right? So let's see, just plus the increment by this one, right? So, and then similarly we can determine the suffix sum. So this is for I in range. So I'm going to do it in a reverse order. So we start from index n minus 2 because n minus 1 the sum is itself. Then negative 1, negative 1. So for the suffix sum, so it's just incremented by the sub I plus 1, right? So this way we set down the prefix and the suffix sums. So next we just need to iterate over the indices to get the minimum average difference and then get the corresponding smallest index. So for this is just a for loop for I in range n, right? So the left average will be for index I, we need to consider I minus 1 terms. So this is corresponding to pre-I, right? Then the number of terms is I plus 1, right? So here we need to do integer division as noted here, right? And then what we want to do is that if I does not equals to n minus 1, then the right average is nothing but the sub I plus 1, because for the suffix we do not need want to include the current number at index I as indicated here. So we have the first I plus 1 element and the last n minus 1 minus I elements, right? So the number of elements here is n minus I minus 1. I plus 1 is the elements here, the elements counting, right? So this is for I does not equals to n minus 1. Otherwise, that is I equals to n minus 1. In this case, because the right sum is 0, so the average is 0 according to the note here, right? And then we just need to prepare the return. So we have initialized this average difference and the index above. So now let's do the same, right? So what we're going to do is that let's see, the temp will be the difference, the absolute value of left average minus right average, right? So now if temp is less than average diff, then what we're going to do is that we set this average diff to be temp, and then we set the index to be the current I, right? So notice that if temp equals the previous state of average diff, so we do not update index, right? So with that said, so we are going to return the final state of index. So this forms one solution format for this problem. Let's do a check. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. So this is the one solution format. So notice that we always have that. So the total sum minus the prefix sum will be the red part sum. So actually we can do another solution. So here, let me copy this part. I'm going to change this one to be solution V1. And then I'm going to change this one to be V2. And then we use one of the prefix sum or suffix sum. Then we can do this. We use prefix sum and the total sum. So the total sum can just need one computation, right? So we can do S equals sum of nums, right? And then we do the computation and put it here. And then, so we just need to set the prefix sum. So let's delete this part, and then delete this part. So here we are setting the prefix sum, then we do the average. So this is the left average, and then if I does not equals to n-1, so the right average, so we just need to do this, s minus pre-I, right? So then the right average is 0 if I equals n-1. This does not change. Then that's it. So this is the second solution format, right? So notice again, so with temp is less than average diff, we do not update index. If it's equal to the average diff, we do not update index. The reason is that we need to return the smallest index if there is a tie. So with that said, we are ready to check this version of solution. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. So with that said, I guess that's about it for this specific problem. So in this video, we solved this problem using partial sums. So depending on our preferences, so we can use both prefix sum and suffix sum, or we can use one of the two and then together with the total sum, so we can achieve the task also. So with that said, I guess that's about it for this video. Thank you.